Hi there, and welcome to part 7 of our Learn to Program tutorial series. In this part, we're going to talk about looping. So, in all the previous episodes, whenever we wrote a program, we executed the statements one after the other. We just learned last time how to branch, how to make conditional statements, which are only executed when something is true. This is all very well, but it's quite limited in its expressiveness in terms of what kind of programs you can write. We really need looping. We need the ability to repeat things again and again. There's many scenarios where this would be the case, like measure some temperature. Is the temperature higher than a certain value? If it is, take an action, open a window. And then again, measure the temperature again. Is the temperature below some value? Has it cooled down enough? If so, close the window. And this would be something that you would repeat over and over again, possibly forever, checking the temperature and then closing or opening the window accordingly. You can't do that procedurally with just sequential statements, otherwise you'd have to have an infinitely long program. So you need loops in order to be able to perform this kind of computation. There are two kinds of loops that we can perform principally in C. There's the for loop and the while loop. Now before we look at those, I'll just briefly cut to completing the exercise that we set in the last episode, which was how to read in digits from the standard input stream using only get C.
Good. I hope that was clear to you.
Set. So let's begin by looking at the for
last
loop.
week's exercise was to read a two-digit number in using getC and with reference to the ASCII character set. So let's have a look at the solution. So what we first do is declare space to store the number that we're going to read in and space to store each character that we read in. Now, if we'd got further on, we could use functions, we could use loops, but we don't have those at the moment, and we're going to cover loops in this tutorial. So we're doing this without loops and without functions. So what do? So first of all, we ask for the user to enter a digit. Then we get our first character from standard input. We then check if the character is less than the character 0 or the character is greater than the character 9, that means it's not a digit. So we print out invalid number, exclamation mark, and return 1. So we exit the program. Otherwise, we add to the integer variable number, which starts with a value of 0. We add on, so this means plus equals means number plus number equals number plus, and then the following value. And it's the character that we read in minus the ASCII character 0. Now to understand how this works, well, imagine that C was the ASCII character 0, so someone had entered 0. Then what will happen is 0 minus 0 will be 0. Now this is... So how does this work? Well, we need to look at the ASCII character set. So when we read in the character, it's not just an ASCII character, it's also a number. As we said, a char type is also a number. So this is also a number. So these are both numbers. And when we perform the subtraction, this will give us another number. And if our ASCII character C is 0, then the number representation of these two things will be equivalent. And so when we subtract 0 from C, we will get 0, which is what we expect. But it will work for all the other digits. And if we look at the ASCII character set in decimal, then what you can see is that 0 will be at 48. So it's the number 48 if we convert it to decimal, their character value. And they're all in a row. So position 49 is 1, position 50 is 2, and so on. So what that means is that if we take any character, so say we read in 5, and then we subtract 0 from that character, what we're really doing is subtracting 53 minus 48, which is 5, which is equal to the number. So I hope that makes sense. It's because we're subtracting essentially the first digit in the row of digits that always works, and because they're sequential. So that works, and look at that a bit more if you don't understand it, but you should be able to convince yourself that that will always work. So that gives us our first part of the number. Now we need to get the next character. So we read in the next character. If the next character is a new line, that means the person just put in a single digit number, and we say we got the following number, and we print out the actual number they got, and then exit the program. Otherwise, if it's not a new line, that means they entered another character. So we again check and see if the next character is also a digit. If it's not a digit, then we return 1 and say it's an error, because it wasn't a new line and it wasn't a digit, so it must have been something weird. Otherwise, what we do is we know that C is a digit between 0 and 9. And so we take our existing number, the first digit we read, which will be the leftmost digit that you typed. And we know that that must be in the tens column. So we multiply the number we've got, multiply it by 10, and then we add on to that number, again, the value of the digit. So we perform that again. Then, so we've got our 2 digits, and we've got our number. So all we need to do now is look for the new line that terminates the input. So we get our third character, we check if it's a new line. If it's not a new line, then we say invalid number, because it must be some garbage character. Otherwise, we just print the number and we're done. So to illustrate that this works, I've already compiled it, but I'll compile it again. If I run the exercise, so let's enter some garbage, invalid number. Let's enter a 1-digit number, got 3. Let's enter a 2-digit number, got 33. If we enter in 33 followed by an A, invalid number, because we have to, in our program, we've said after our 2 digits, a new line has to follow. Alright, so that is the answer to the exercise. Let's get on and discuss loops.
Let's start with the for loop, since this is the most common loop used, I believe. That seems to be anyway. The syntax of the for loop is as follows. For, the keyword for, open bracket, then we have initialization statement, so I'm just going to put in it as a placeholder. We have a semicolon, then we have a condition, which is true or false, another semicolon, and then we have an update statement, followed by a close bracket, and then a brace, and then a close brace. So we can put whatever statements we want within the scope of this block. And what happens is, this statement here typically initializes a variable which is checked in the condition. And then the loop is only executed whilst the condition is true. After each execution of the loop, the update statement is executed, and that typically updates the variable until at some point the condition will be false, in which case we break out of the loop. That sounds a bit cryptic, so let's look at a concrete example of that and it will become clear. So say we want to make a loop that just prints out the numbers 1 to 10. We could do the following. For int I equals 1, I is less than 11, I plus plus. Printf right, so what this will do is we come to the for loop, And in our initialization part of the for loop, we create an integer called I and give it the value 1. You don't have to put anything in the initialization there, and I could be declared outside of the loop. One of the advantages of declaring an integer here is that its scope remains within this block, and you can reuse the same variable in future loops. Again, that can often be less confusing, but you don't have to. We haven't really covered scope in that much detail, but what it means is that this variable only exists within these two braces if you declare it in here. So I initially has the value 1. We check the condition, is I less than 11? Well, it has the value 1, so it is. So we go through and we print out the value of I. After each execution in a loop, we then evaluate our update statement. So we've gone through once, and now I gets the value I plus 1. That's what I plus plus means. So I is now 2. So we again check the condition. Is 2 less than 11? Yes, it is. So then we execute the loop block again and print out 2. This carries on until we've just printed out 10. We then go to the update statement and I becomes 11. We then check the condition, is I less than 11? And no, it's not, it's equal to 11. So the condition is now false and we exit the loop. So we printed out numbers 1 to 10. Let's take a quick look.
So let's create the most basic for loop we can. In our make file, we've got hello for loop as a default, and this is just called hello underscore for loop. Now, let's just do what we did on the board. So for in I equals 0, sorry, we're starting from 1, I equals 1, I is less than 11, I plus plus. Print f, and we're just going to print out the value of I. If I now make that and then run it, you see it just prints out the values 1 to 10. Pretty straightforward, eh?
Since we haven't encountered scope before, we should probably introduce it now, since this is the first time we've seen it. So the scope of a variable is where that variable can be seen. Before, we had our main function and we declared our variables inside the main function. When we declare them, they are visible, that is, usable, from any point after which they are declared. So if we declare x up here, it's visible to the rest of the main function until this closing brace. So it's also visible inside this block. So this is called a block when we have a opening brace and a closing brace. This is also a block. So we have our main block and we have a block for this for loop. X is visible in both our main block and inside the for block, because it will be visible in any nested blocks. We can also put variables outside of the main function and declare them in the file, and then they will have the scope of that file, compilation unit as it's called. This variable here, or any variable declared in the initialization part of a for loop, will only have the scope, will only be visible within this block, within the for loop block. So we can't refer to I here, it doesn't exist outside of this block. This is important. So you might be wondering, well, what happens if we have an I outside of the block? Can we do that? Can we declare an I outside of the block? What will then happen? Let's have a look.
So let's take a look at that. We'll declare a variable called I outside here and we'll give it the value of 33. Then we'll have a for loop. We're only going to print the values 0 to 9. and then we'll print out the outside version. Now let's have a loop. Will this actually compile? Yes, it will, and there's no errors, so it's valid to do that. We can have two variables, both called I, because the scope of this one in the for loop is limited to that for loop. And let's see what happens when we run it. Alright, the first 10 values are printed, the inside I, and you can see that the outside I has not been changed. If we had another variable called x, and we actually set x to I within the loop, and then we try and run that, we obviously need to print its value out. There we go. So x at the end of it has been changed because x is visible within the for loop. So ordinarily, when you change a variable that's declared outside of a for loop or declared outside of a nested block, you can change its value within it. The only exception to that is if you had a variable that clashes in terms of its name, in which case the innermost definition will be assigned to.
So the other type of loop in C is called a while loop, and it has the following syntax: while condition, and then we have our block where we put our statements. And this is pretty straightforward, and it kind of goes as you would imagine it would. So if this condition is true, then the loop executes. So what it means is, do this while the condition is true. If the condition is false at the very beginning, then the loop will never be executed. So to give an example of how you typically might use this, we use the same example as before. So we could have int I equals 1, and then we could write while I is less than 11, print I out, and then we could do I++ here. And that would be the same as the for loop that we looked at before. First of all, I is 1, so the condition is evaluated, 1 is less than 11, so execute the loop. I is incremented, so then I is 2, and so on until I is 10 at the end of our last time around the loop. We increment it, it becomes 11, so I is no longer less than 11, and the loop exits. That's a while loop. It's very simple actually.
So here we go with the while loop. So we again declare a variable, and then we can say while I is less than 11. Print out our I value, and then increment I. Let's see what that does. Again, it just prints the values 1 to 10. So I is initially 1, this is true, 1's less than 11, prints it out. I is then 2, I is then 3, and so on until I is 10, in which case this is false and it exits.
Another way we can write that, and you quite often see people using a while loop like this, is the following way. So we still have our I, but then in our while condition, we just put a 1. So we loop forever, because 1 is always true. And then inside the loop, we do something like this. If I equals 11, and then we use this special keyword break. And what that does is, if I equals 11, then we break. And that means we break out the while loop, and we just smash that out. And we're exited the while loop. And then we could have our I++ down here. So this would again loop 10 times, but it does it in a slightly different way. It's slightly less readable. Often where you will see it written like this, as if lots of complicated things are done inside this loop, and there are many different conditions under which it can break out of that loop, in which case it makes a lot more sense to do it like this.
We can loop forever, so while 1, and then we can say if I equals 10, sorry, if I equals 11, then break. Otherwise we print it an increment, and if we compile that, has the same effect. We've broken out of the loop. We could also put the break statement down here. So we could go through and break out at the bottom here if we wanted. It's exactly the same. So that's what you can do with while loops.
I just want to point something out about the for statement. You will sometimes see this. Now in the for statement, any of the initialization, the condition, or the update can be empty. If the condition is empty, then the compiler says that it's true. So an empty condition means true. If you run this, then because the condition is true and always true, it's not going to stop being empty, then this just loops forever. So this is the equivalent of saying while 1, so while true. But you still see people doing this, which is a bit weird, right? It's not very readable. If you want to say loop forever, or do something while true, why not use while true? The reason is historical. Apparently, on some old compilers and old machines with particular instruction sets, when the moon was at a particular orientation, this would be quicker. It would evaluate to a slightly quicker machine instruction. So people would say, use this, use this. But if you do any search, or if you just compile this yourself and then disassemble it, you'll see that these are actually just equivalent. They use the same opcodes, they use the same assembly instructions, so there is no efficiency difference anymore on modern compilers.
It's worth taking a quick look at that, even though this is probably a topic that's 10 episodes ahead. Well, so what I've done, I've created 2 programs, one called forTest and the other one called whileTest. And you can see that they are identical, except on the left here we have a for with an empty condition, and on the right here we have a while with a true in its condition statement. But otherwise they're totally identical. And if we compile them both and run them, you can see that the output is identical. So the output's identical, they behave identically. Now if I use a debugger called GDB and I open up each of these programs, and then I disassemble main, so I disassemble the program, you can see there that the assembly is absolutely identical. So there is no efficiency gain doing it one way or the other. This is because of modern compilers, they have optimized out any minor inefficiencies like that, and they did that a long time ago.
So don't use this because it's not very readable. If you mean while true, write while true. There's another variant of the while loop that you can use, and this is called a do while loop, and it looks like this. Do, open brace, statements, close brace, then while, condition. Now, So what this will do is it will always execute this code block at least once, because the condition is evaluated at the end of the block. So you might be thinking, what is this useful for? Why would you use that? And I had to think about it for quite a while actually, because I hardly ever use this. I can't remember the last time I actually used this. I usually use some other kind of structure. But there are cases where, if I think back, where you'll be doing something in this block that is quite an involved piece of code, and you have to do it for the first item in a list of items, and that determines whether you do it for the rest of the items. And if you have the condition at the top, what you end up doing is having to put this code block again outside the block to do it for this first item. That's a bit cryptic. Okay, I'll try and think back to what we've already covered. So imagine if you were taking input from the user with getC, and you were asking the user a bunch of questions about configuring a program that's running. Well, it might be that the first question you ask them is, do you want to configure the program or use the defaults? And you always ask them that. But in this block, you could have the code for that, for processing that, and processing all the other questions that come up. Maybe 5 questions come up with 5 different options. And then you might want to go through it once to examine the case where, do you want to configure it or do you want the defaults? And then if they say they want to configure it, then it can go around and do the next bit. Otherwise, if they say they don't want to configure it, this condition could say false and it would exit, or exit this loop. And the reason you might want to do that is because that code for processing the first option, do you want to configure the program or not, might be the same code as for processing all the other options. If it's something very simple like, you know, read a number in or whatever, it might just be repeated. You don't want to repeat all that code up there. I'll show an example of this, but as I said, I hardly ever use it. Perhaps you'll find uses for it.
So just to illustrate that, we can write our program, do while, let's say I is less than 11. And then we might have our printf statement here, and increment I here. And let's just compile that and run it. Alright, yeah, I said we started from 1. There we go. So that prints out 1 to 10. So in that case, it's just identical to what we did before. And, you know, so to begin with, the condition is actually irrelevant because the condition is only evaluated at the end. So to begin with, we just print out 1. Then we get to the end and compare. We increment I first, so then I is now 2, and then we compare it against the condition. So when I is 10, it will go around one more time, but then I will be 11, then it will break out.
So you saw that in a while loop, you can use break to break out early from a loop, and you can use that in a for loop as well. You can also use another keyword called continue. And just to illustrate what that does is, so say we had a for loop. And we're just looping from 0 to 9. What we could do is we can say if I equals 5, continue. And perhaps we've got some other statements down here. And what this will do is when I is 5, it will just go straight back up to the top of the loop again. It will run the update statement and continue. So it's essentially like skipping the rest of the statements in the block. It's equivalent to saying if I equals 5, do nothing, else do all the other statements. It's just a quick way of getting back to the top of the loop. So why might you do this? Well, usually it's when you don't want to bother doing a bunch of computation on things you're not interested in. So say you were processing a load of numbers and you're only interested in even numbers, you could check if I is odd, and if it was odd, then you press continue, right, continue, so that you go back to the top and go to the next number. Whereas if I is even, then you carry through and do all the heavy computation. That's because you don't want to do all the heavy computation if I is not even and then just throw the value away, which is what you might do if you didn't have that in there. So that's what continue is useful for, and it's used quite a lot, and it's quite a useful statement. You can also, within a block, you can return from whatever function is encapsulating your loop. So if we just have the main function and we're in our programs that we've seen so far, if we put return in here, that will actually just return from the program. We've got to return a value in that case, so we return 0 and we'll return from our main function and return out. When we get into general functions, we might return some other value. And the reason that's useful again is because if we were searching for something with our loop and then we find it, then we just want to return immediately rather than going through the rest of the loop and wasting our time like that. Alright, let's look at those examples, but we're pretty much finished now with loops.
So let me just illustrate both break and continue. You've already seen break where we used it in a while loop. So I'm going to define a for loop here. And we're just going to loop from 0 to 9. Now perhaps we're processing these numbers and for whatever reason, perhaps we don't care about the numbers 2 and 5. So we could say if I equals 2 or I equals 5, then continue. And what continue will do, it will then stop, it will jump straight back up to the top. So it will stop processing the loop, it won't bother executing the rest of the statements down here, it will just jump back to the top. So it continues with the next iteration. It will still evaluate the update statement and then evaluate the condition. But it won't do any of these statements here. And let's just print out our I value here so we can see this. And then what we can do is we'll say if I equals, tell you what, if I equals 9, then we're going to break. Just so we've got both of them in there. Now if we run that, hello break continue, what we print out is 0, 1. We don't print out 2 because we continued, so we didn't get to the print statement. We print out 3 and 4. We didn't print out 5 because we continue, so we don't hit the print statement. 6, 7. We get to 8, print 8. Then we get to 9 and then we break. So we never actually get to 10 because we prematurely exit the loop by breaking out of it here. So you can also return from a loop. So you can return, and then what that will mean is that we will essentially return from the main function outside of the loop. You can also exit from a loop to exit a program. And to illustrate that, let's just run this again, but print out outside for. So if we run that, it prints out outside for, because we just broke outside the loop, but we still execute this statement and finish the program. If we return 0 here and then run this, we do not print this line because we immediately return from this main function. When we've got other functions, what this means is that we can return from those functions.
So that's looping. I hope that was useful, and you can see it's pretty straightforward. But now your programming skills are expanding. You can execute linear statements, you can branch, you can loop, so you can do some pretty cool things now. All we're really missing is arrays and functions, and then you'll be able to do some very powerful things. And we'll get on to those in the next couple of episodes. So thanks for watching, and see you next time.